All right, this is target 3A, and the long title is Describe the domain of a function from its graph and relate the domain of a function to its graph in a real-world context. Wonderful. Um, Basically deals with graphs. So your objectives. You will be able to identify the domain of a function when given a graph and any restrictions on y. And you will be able to determine the domain and range of a real-world problem based on information contained in that problem. So just a refresher, inputs, x values, or domain. Okay, remember, these are all the same. Okay, you need to remember that. If you didn't get it last unit, remember that these are all the same. So if you're presented with points, these are your x values. If you're presented with a table, these are your x values. If you're looking at a graph, these are your x values. Because notice, okay, here's a point. This would be like, oh, that's a bad color for that. Anyway, this point here, right here, that would be -5, 1. And your domain or x value would be -5, for example. Okay, your outputs or your y values or range, again, all the same. Okay, these all mean the same thing. So given points, that would be all of these. Given a table, that would be these. And given points on a graph, that would be all these, because you have a point here at 4 on the y-axis, at 3 on the y-axis, at 1 on the y-axis, and at -5 on the y-axis. All right, so let's start with a problem. This is practice, example, whatever you want to think of it as. Given f of x equals -1/2 x plus 3, so that's this graph, and the restrictions, y is greater than or equal to 1, and less than or equal to 1.5. Okay, so when you see this, this means on your left is always going to be your minimum, and on your right is always going to be your maximum. Right? And that means that y has to fall in between there. These are important too, because they tell you if these points are included in that. Remember, if it's got the line underneath, it means, like in this case, y is greater than or equal to 1. So 1's included. If it was just the greater than sign, then the 1 wouldn't be included. And on this graph, it would have to be represented with an open circle, like on a number line. But anyway, we need to find the domain. So we need to find the x's. So we've got the line already. So this part is really kind of a moot point. We don't need this. This just says that this goes with this. What's important here is this right here. All right. So what this tells us is that we need to find out what our x's are when y is between 1 and 1.5. Well, here is y is 1. I'm going to change this color so you can see it better. Okay, so here's y is 1. That's 1 right there. And 1.5 is about in between. So that's right there. So we put our points there. So we start off by marking off points on the line where the value of y is at its minimum and its maximum. Okay, next, the domain is that x values of the line in between these two y values. So we've made our two dots. Now we need to identify what this is in here. So we go down and we look and we see, oh, well, look at this. X is anywhere between a minimum of 3 and a maximum of 4. So we can say the domain is x is greater than or equal to 3 or less than or equal to 4. Okay, a little bit more practice. Find the domain given the graph below. Now notice this one isn't a line. These have dots on the end and they're filled in dots. So, and we just have a graph. We have no restrictions. So we've got to look at these two dots here. All right. And one, they're closed dots. So that means that we are going to have our symbols are going to be like this. All right. So we need to find what x is. Well, all you have to do is look at the x-axis, because here's the x-axis right here. Where do these dots come down to? Well, x is 0 there, and x is 3 there. So your smaller number is always going to be on the far left, Your larger number is always going to be on the far right. And you're just going to plop x in between, so you can say the domain is x is greater than or equal to 0 or less than or equal to 3. Be careful of these, okay? We've got a few examples here all wrapped up into one. In this case, we have array, so it has an endpoint, but then you notice that it has this arrow, and that means that it keeps going in that direction, okay? So this open point is going to tell us a couple things. One, okay, it's going to tell us that it starts there, but it doesn't include that point. And then the arrow tells us that it goes on for infinity, basically. It keeps going. This one has arrows on both ends, so this line continues forever in either direction. So for this one, the domain is x is greater than -5. The open dot is why we don't have the line underneath. So we don't include that. So it's just greater than because it's going to the right and the numbers are getting bigger, which means that that x is going to be bigger than this, and -5 is where that point is at. For this one, since it keeps going in either direction, it gets really easy. We just say all real numbers. So if you have a line, meaning you have arrows at both ends, you can say the domain is all real numbers. All right, let's try a word problem, because I know how much you guys love these. So, Notre Dame Stadium is capable of seating 80,795 people. Yes, I looked it up. Yes, that's correct. For each game, the amount of money that the university brings in as revenue is a function of the number of people, which we're going to call P, in attendance. So if each ticket costs $40, find the domain and range of this function. So a couple things. Domain and range, unless it's x is all real numbers, is always going to be written as an inequality. Okay, it's never going to be equal. So this sign, don't use it. No equal sign. It's going to be this, or that, or this, or that, depending on where you put your variables. So anyway, in this case, first step, begin by writing the function. This is an easy one. There's no constant, there's no base value, there's none of that. There's only the $40 per person, and we said that P is the number of people. Each ticket costs 40, so we're just going to say 40 times P. Okay? Next, remember that the domain is the input, and in this case, the number of people. Range is the output, or the number of people times the cost of each ticket. So to find the domain, or to find the range, all you have to do is take that 40 and put in the maximum number of people, 80,795. Okay, and you can't have less than 0, so we know that 0 is going to be our lowest number. I mean, you could have no one show up at the game, but you can't have a negative amount of people show up at the game. So for your range, it's going to always be, for these types of problems, it's going to be y is greater than or equal to 0, and then less than or equal to whatever you get by multiplying those numbers. Okay, in this case, $3,231,800. And the domain is simply because we said that P is people, and that was the domain, so we could have 0 people show up, or we could have 80,795 people show up. So x has to be greater than 0, has to be, so it doesn't have that. We're not going to say equal to 0. We're just going to say x has to be greater than 0 or less than or equal to 80,795. Some tips. Find a way to remember that domain equals x equals input, and range equals y equals output, and also f of x. Just as a way to keep that fresh in your mind too. And again, make sure that your answers for the word problems make sense. Okay, so you're not going to come up with like an answer of $40. So make sure your answers make sense. That's it.